Good morning, students. So I welcome you all to today's lab class of the subject Machine Learning and Data Analytics using Python. And the topic that we are going to cover today, it is linear regression using Python. As you know that in the last lab, this is our second lab. And in the first lab, I have already covered the COs, the course objectives of the lab. And also I have give you the overview of that what programs, what experiments we are going to do throughout the semester. So today we will start with the very first experiment, and as you can see the heading, the linear regression using Python. Okay, so the implementation will be in Python, but before going towards implementation directly, I just want to give you an idea that why we are doing linear regression, what kind of problems we can solve with linear regression, and how the model of linear regression works. So can you see that I have one table? This is actually a data I have. Okay, and the data is in the form of a table. It's a tabular form data. And what the data says that this data, this whole data is about prices of the home in some city of USA, right? That is Monroe, TWP in New Jersey. So the area of the house and its respective price is mentioned in the table. For example, if the area of house is 2600 square foot, the price will be 5,50,000. If the area is 3000, the price will be 5,65,000. And so on. There are total how many elements given to you? Total 5 elements. Right? In the very first column, the area is mentioned. In the second column, its respective price is mentioned. Okay. Now this data we will feed to our machine. Okay. Why we are feeding this data to our machine? Because in this data, area and its respective price is already mentioned. So I am giving it a training set, a supervised data set. Supervised means for input, the output is already given. You know that your teacher is your supervisor. Why your teacher is your supervisor? Because your teacher knows for every input what will be the output. For every problem, your teacher knows the solution most of the time. Similarly, for area, for particular area, we want to calculate the price. But here in this table, for every area, its respective price is already given. This is known as a supervised learning. Okay, where you first feed the proper data, the input and its respective output into the machine. This is known as supervision. Okay. After that, these home prices that I have explained, right? Now its prices are also given. We will feed this data. Now what will be our next step? Our next step after feeding this data into your machine will be that if I will now give my machine a new data. For example, I will give machine area 3300. Can you see 3300 is not present here? Right? Here 3300 is not present. So it means for area 3300, what will be the price? You can't get it from this table. But as your machine is trained that for 2600 it is 55, for 3000 it is this, for 3200 it is this. So now your machine can predict. Predict means it will give you a rough idea that what will be the price of 3300 square feet area of house. Similarly, I am giving it one more new data set. Okay, what will be the price of 5000 square feet? So using this data set, it is going to predict it. Okay, so what is the basic idea, students? The basic idea is first you feed the proper input and output data to your machine. This is your input and output data. Next, what you do? You give it a fresh set. You give it input, new input, and you ask your machine to predict the output. So if I just look at this data, this one data that I had, this one, okay, for area and for price, we can plot a graph. How? If I am plotting the area on the x-axis and I am plotting the price on the y-axis. Okay, so can you see for 2600, what is the area? Sorry, for 2600 area, what is the price? It is 5,50,000. So can you see here for 2600 area, what is the price? It has given us a mark here. Okay, for this area, what will be the price? This. And where it is intersecting? It is intersecting here. Okay, next for 3000 area, can you see from here for 3000 area, what was the price? It was 5,65,000. Okay, so for 3000, it is 5,65,000. Yeah, so somewhat here. This is 75,000. So it was low from that. It was 5,065,000. Next is for 3,200 area, the price was 61,000. So this is 60. So it was a bit above of that. Okay. So can you see that how it is predicting all these things? Right. So what model we can follow here? We can follow here that these points, they are coming very close to a straight line. So if I create a straight line, right, that is actually in which actually this is the x-axis, this is the y-axis. Okay, this is my x-axis where I am predicting the area. This is the y-axis where my price is already given, right? So these points, right, that tell what will be the price for a particular area, they are coming very close to a straight line. Although they are not coming completely on the straight line, they are very close to straight line. Okay, so if I want to predict a new thing, for example, the next was 3,300. For 3,300, using this, I can predict it. Okay, for 3,300, I can predict it because here the prices are not given. On the basis of straight line, I can predict, okay, it will be close to this, right? This one. Something close to 6 lakh and I guess 17,000. Okay, and if it is mentioned that for 5,000, so if I just increase it for 5,000 and this line is going like this, so it will be something like that. Okay, we will plot it according to that. Now we are just taking this much data. Okay, so the actual data model that we are using here is a line. You know that whenever a line is there, the model is always known as a linear model. Linear model that on the basis of this, on the intercept of the line, you can predict the price. For this, on the intercept of line, you can predict it. Okay. Now, for example, for 3,300, I have predicted it here on the basis of this line. Okay. So suppose it was somewhat close to 6,18,000. Okay. But actually the price is, actual price is 6,20,000. It means 20,000 means here. So it is still close. What is the error? Error is of only 2,000. That error is very minor. Always when we go for buying houses, we always start with the guess. And this is a very good guess that our guess is 6,18,000. But when the actual price that person told us, it was 6,20,000. Okay, so we can say that our guess is very correct. Okay, so I am predicting rest of the points of area which are not mentioned on the basis of this line. So this is the same thing that I was saying, that using this linear line, right? Now I am able to predict the price of a new house whose area is 3,300. Okay, so how I am able to predict? I have simple taken that point 3,300. I have created an intercept here with the line. Okay, so here 3,300 is meeting at this point on my straight line, which is of the blue color. And from that line, if I draw one horizontal line, so it is giving me an estimated area of 6,28,715. So this is the predicted value. Got it? These points I have plotted. It has given me it has given me a hint actually that a straight line model can work. Okay, although it will not be the perfect prediction, but predictions are never perfect. They are always close to the actual value. Got it? So here and here. Okay, so suppose a new value comes 3700. That for 3700 area, what will be the price? So similarly, it will plot one line. It will intercept this blue line, and from there it will draw one horizontal line, and it will give you a close cut that it will be here. Okay. Okay. Now what this diagram is explaining, that although you can see that the points, the whole points, they are not fitting completely on the blue line. Okay, this is one point, it is away from blue line, it is also away from blue line, it is also away from blue line, it is also away from blue line, it is on the blue line only, right? So why we are taking the linear line as our predictive model, the linear regression, although there are so many lines that you can draw. Okay, if you try to cover all the points on a line, I want to cover that this point should also come, it should also come on a line, this point should also come on a line, this point should also come on a line. So you can create multiple lines. See, this is one line, the orange one, which is covering this point, right? Then there is this red line, this is covering this point. So other than this blue line, I have created two more lines. To cover this, I can create one like this. Okay, so there are so many lines that you can draw, but why we are going for this one? Because the distance always matters. Okay, so see students, if I am drawing this line, although this point is covered, the distance between the other points and this line is increasing. So I should choose a line in which all the points should be at less distance from your main line. Okay, my motive is not to cover a one point on a line. My motive is to cover all the points in a way so that their distance should always be less from the main line. Okay, so this is not covering that, this is not covering that. This linear model covers everything. Okay, so see, the same thing is mentioned here, that this blue line, which I think is perfect. Why it is perfect? Because in this line, the distance, so suppose this is one distance from this point and I have named it delta 1. This is the second point and its distance, I have named it delta 2. Okay, this is the third point, it has some distance, I have named it delta 3. This is delta 4. Okay, and this is delta 5, although the distance for delta 5 is almost 0. Okay, and when I do the summation, I add all the deltas. Okay, delta 1 plus delta 2 plus so on. How many points I have? Here I have total 5 points, so it will go till delta 5. I will add all the distances, right? Delta I mean all the distances, and this summation says that from 1 till n you are adding them. Got it? All the distances you are doing the sum of them, and after doing the sum you are doing the square. Why I am saying this thing, that this line is at less distance from all the points. Why I am saying? By calculating this. If you try to calculate this with other lines, you will obviously feel that this distance is, this whole thing is increasing. And what our motive is, that when we do the distance sum and then square, the final output, suppose delta, it should be minimum. So our main motive is to minimize that overall value. Okay, for this line, this value will be minimum if you compare it with the other lines. Okay, so if it is the minimum one for a line, it means that line is the best one. Okay, and we don't need to check for linear models. For linear line, it will be minimum as compared to other lines. So now I have reached at a conclusion that lines are the best way, right? Either this line uh, or this line, whatever line. Okay. So whenever a straight line comes, whenever you have x-axis, you have a y-axis, and there is a line, this kind of line, this kind of line, this kind of line comes, they comes under the category of straight line, or in machine learning, we say linear regression, linear line. Okay. And you know that there is one formula for the straight line. If you have heard in mathematics, it is y equals to mx plus b. Can you see this one? It is y equals to mx plus b. Okay, where m is the slope. Every line has a slope. So m represents the slope and b represents the intercept. Which intercept? Y-intercept. So suppose this is x-axis, this is y-axis, and this is a line. So what is b? B means from here, what is the distance at which it is intersecting at y? This line is intersecting your y-axis here. So from 0, this distance is known as b. Okay. And if your line is passing directly from the 0, there is no intercept, right? It is not intercepting on y-axis, it is in the center. In that case, the line's formula will become y equals to mx plus intercept will become 0, and it will be only y equals to mx. So this is the formula of straight line. Okay, so now I am going to put this formula in my current problem. Okay, so now y is the price. I am referring to y as the price, which is correct because on the y-axis we have plotted the price. Equals to m. On the x-axis we have plotted the area. M into x is represented as area plus b if there is any intercept. Now students, if area is given to me, I know the value of slope, I know the value of intercept, I can calculate the price. Okay, so you can see here that this price, other than these two variables, this price is directly proportional to area. Okay, so if area is given, I am able to calculate the price. So the same thing that I have mentioned here, this one. Okay, so I am writing it again, that your price is equals to m into area plus b. Okay, so this that we want to calculate, it is known as the dependent variable. It is depending on something, right? On which it is depending? It is depending on area. Okay, if area is increasing, the price is increasing. If area is decreasing, the price is decreasing. So that's why your price is directly depending on area. So that's why it is known as the dependent variable. Obviously, if it is dependent, that's why you are calculating it from area. On the other side, this is known as the independent variable. Area has nothing to do with the price. You will get the area first. On the basis of that area, you will calculate the price. Okay, so if you want to calculate the price, I want to calculate the price. What I need first? I first need area. So this is depending on area, but area is not depending on anything. So that's all about the concepts of this machine learning first experiment, that is linear regression. Okay, so now you know that what is the basic idea that runs behind it, and why we are choosing the line model, right? There can be line that is passing directly through the 0, or there can be line which is leaving some intercept. Okay, and which line will be best, how you will judge it, it is always on the basis of that delta square formula that we are using. Okay, minimum the value for a line, the best suited that line will be. There is no need, there is no compulsion that your line will always be passing directly through it like this. No, right? No, it can be here, it can be here, it can be any line. Okay, but which line will be best? we will always check it with the help of that delta square difference. So can you see here that here I have a folder, right? This PC new volume D, and inside that there's a folder Janagas, and then their machine learning, and then lab folder. Inside the lab folder, can you see there are so many files? Some are the PowerPoint files and others are the Excel files, and even can you see this is an Excel file and this is an Excel CSV file, comma separated. Okay, so I will show you this file, this one, home price with the double E. Okay, so let me share it with you after opening it. Okay, let me share it with you. Okay. Can you see this home price? Okay, so I am not feeding the data directly to my model by using any variable like A equals to this, P equals to this. So I have data already there in a file. The name of the file I have explained. Okay, in case this meeting end, you should join again from the same link. So in the very first column, area is given, the same area that I have explained to you in the PPT, and on the second column, there is the respective prices. Okay, so this training data we will use to train our machine. Okay, now students, this training data is in an Excel file, but when we do coding, we open the Python. It means